The Horten Ho 229, the Nazi flying wing that was too late to change the war. In the final months of the Second World War, Germany was no longer fighting for victory in any realistic sense. It was fighting against time. Its cities were burning, its rail lines were shattered, its fuel supplies were shrinking by the week, its airfields were under constant threat. The Luftwaffe, once feared across Europe, had been bled down by years of combat, Allied bombing, fuel shortages, and the loss of experienced pilots. Above Germany, American bomber formations crossed the sky in daylight. B-17 Flying Fortresses and B-24 Liberators flew through flak, fighters, and freezing altitude. Around them came long-range escorts, especially the P-51 Mustang, a fighter that helped change the balance of the air war. By 1945, the Allies were not just attacking Germany. They were strangling it. And yet, in workshops, hangars, and half-ruined factories, German engineers were still drawing machines that looked as if they had arrived from another age. One of those machines had no tail, no normal fuselage, no familiar profile. It was a dark, broad, swept wing. 2 jet engines were buried inside its center. A pilot sat inside a small cockpit near the nose. From the front, it looked less like a conventional airplane and more like a shadow cut into the shape of flight itself. This aircraft became known as the Horten Ho 229. It was also called the Ho 9, and later, under the company intended to help build it, the Gotha Go 229. Today, it is one of the most mysterious aircraft of World War II. It appears in books, documentaries, model collections, museum exhibits, and online debates. Some call it the first stealth aircraft. Others call it the Nazi ancestor of the B-2 bomber. Those claims are dramatic, but the real story is stronger. The Ho 229 was not a finished secret weapon. It did not enter combat. It did not change the war. Only one powered prototype ever flew, and that aircraft crashed, killing its test pilot. The surviving airframe never flew at all, but it was not meaningless. It was real. It was radical. It was dangerous. And it tried to combine 2 of the most difficult ideas in aviation at the same time: the flying wing and the jet engine. That is why American forces took notice when they found it near the end of the war. They were not looking at a miracle weapon. They were looking at a question. What would happen if an aircraft became almost nothing but wing? What would happen if early jet power was placed inside the cleanest possible airframe? And what did this strange, unfinished machine reveal about the future of aviation? To understand the HO 229, we have to begin before the jet age, before the secret hangars, before the myths. We have to begin with 2 brothers and the quiet world of gliders. Their names were Walter Horten and Reimar Horten. They were not originally the heads of a large aircraft company. They did not begin their careers as famous industrial designers. Their story began in the German gliding movement of the 1920s after the First World War, when Germany's ability to develop powered aircraft had been restricted. For young men fascinated by flight, gliders became a doorway. A glider is an unforgiving teacher. It has no engine to rescue a poor design, no throttle to overcome excess drag, no reserve of power to hide mistakes. Every curve matters. Every surface matters. Every pound of weight matters. If a wing is inefficient, the aircraft sinks. If the shape creates too much drag, the flight is short. If the controls are poor, the pilot feels it immediately. Walter and Reimar learned this lesson early. Reimar was the deeper aerodynamic thinker. He became the designer, the man drawn toward clean shapes and unconventional solutions. Walter became a pilot, and later a Luftwaffe officer. He brought experience from the cockpit and from military aviation. Together, they became obsessed with a question that most designers considered too risky. Could an aircraft fly well without a tail? At first, the idea sounds simple. Remove the parts that do not create lift. Take away the tail, shorten or eliminate the fuselage. Build an aircraft where almost the entire machine is wing. But aircraft are not simple. The tail of a normal airplane is not decorative. It gives the aircraft stability. It helps control the nose. It keeps the aircraft from wandering or pitching unpredictably. The vertical fin helps the aircraft track straight through the air. Remove those parts and the aircraft may become cleaner. It may also become dangerous. A flying wing promises lower drag. It promises efficiency. It promises a form where the aircraft's structure and lifting surface become one. But it demands control. It demands balance. It demands an understanding of airflow that leaves little room for error. During the 1930s, the Horten brothers built a series of tailless gliders and experimental aircraft. These were not casual projects. They were steps in a long attempt to solve a hard aerodynamic problem. How do you make a wing stable without a tail? How do you control pitch and yaw? How do you keep the aircraft from becoming unpredictable when speed changes, when the pilot turns, or when the air becomes turbulent? The Hortens experimented with different shapes and control surfaces. Some of their machines were elegant. Some were difficult. Some revealed the limits of their ideas. But each one added experience. By the time war came, the brothers had spent years thinking about something most air forces still viewed as a curiosity. Then jet propulsion changed the stakes. By the early 1940s, piston engine fighters had reached a remarkable level of performance. The American P-51 Mustang, the Republic P-47 Thunderbolt, the British Spitfire, the German Bf-109 and FW-190. These were powerful, refined machines. But they were still driven by propellers. Propellers had limits. As aircraft moved faster, propeller efficiency became harder to maintain. Compressibility effects began to appear. Engines grew larger and more complex. Designers could still improve piston aircraft. But the next age was coming. The jet engine promised that age. Germany pushed jet aircraft into the air earlier than any other combatant. The Messerschmitt Me 262 became the first operational jet fighter. The Arado R-234 became the first operational jet bomber and reconnaissance aircraft. They were not perfect. But they proved something important. Jet aircraft were no longer theory. They were weapons. For the Horten brothers, the jet engine created a new possibility. A flying wing had always promised low drag. A jet engine demanded low drag to make the most of its power. Put the two together, and perhaps the result could be extraordinary. That was the heart of the Ho 229. The project grew around a brutal and ambitious performance idea often remembered as the 3 × 1,000 requirement. 1,000 kilograms of payload, 1,000 kilometers of range, 1,000 kilometers per hour. In American terms, that meant about 2,200 pounds of ordnance, a range concept of more than 600 miles, and a speed around 620 miles per hour. For the early 1940s, those numbers were breathtaking. They were also deeply difficult. The early German jet engines could produce speed, but they consumed fuel rapidly. They were fragile. They required materials that Germany increasingly lacked. They were difficult to maintain. They could open the door to the future, but they could not erase wartime reality. This is where the flying wing concept mattered. A conventional aircraft creates drag from many places. The fuselage, the tail, the engine nacelles, the joints, the protruding surfaces. A flying wing could reduce much of that. In theory, it could move through the air more cleanly and get more value from every pound of thrust. That made the Ho 229 more than a strange shape. It made it a serious engineering answer to a real wartime problem. Germany wanted speed, it wanted range, it wanted striking power, and it wanted all of that at a time when its resources were collapsing. The Ho 229 was pursued because it promised a shortcut, not a safe shortcut, not a proven shortcut, but a shortcut that looked just possible enough to attract attention. Hermann Göring, head of the Luftwaffe, showed interest in the concept. The Horten brothers received support to move the design forward. But that support should not be mistaken for proof that the aircraft was ready. It was a gamble, a dangerous gamble. And the deeper we look at the machine, the more clearly we see both sides of that gamble. Imagine standing in a German workshop in 1944. The air smells of oil, wood dust, metal, and glue. On the floor sits an airframe that does not look like a fighter. It does not have the long nose of a Mustang or the sharp fuselage of a Messerschmitt. Instead, the entire machine spreads outward as one broad wing. There is a cockpit in the center. There are engine spaces buried inside the body. There are no tail surfaces rising behind it. To a mechanic trained on normal aircraft, it must have looked unsettling. To a designer obsessed with drag, it must have looked beautiful. A flying wing is easy to admire from a distance. It is harder to make work in the air. The Ho 229 used sweep in its wing planform. Sweep helped with high-speed flight and contributed to stability. The aircraft used control surfaces on the wing instead of a conventional tail. These surfaces had to handle jobs normally divided among elevators, ailerons, and rudders. In simple terms, the wing had to lift, balance, steer, and stabilize the aircraft all at once. That is a heavy burden for one shape. The airframe was also a mixture of modern ambition and wartime improvisation. The center section used welded steel tubing. This carried major loads and supported the cockpit, landing gear, and engine area. The outer wing structure relied heavily on wood, including plywood skinning. The surviving V3 airframe shows the importance of wood, adhesives, coatings, and careful construction. This was not unusual for wartime Germany. Strategic materials were under pressure. Aluminum was valuable and increasingly scarce. Wood offered a way to build large structures without consuming as much critical metal. But wood in a high-speed jet was not a simple solution. The quality of the wood mattered. The glue mattered. Moisture mattered. Fit and finish mattered. A flying wing depends on clean surfaces. A jet aircraft pushes those surfaces into a demanding speed range. Any weakness in construction could become a serious problem. The Ho 229 also used tricycle landing gear, with a nose wheel and main gear. That arrangement is normal today, but in the 1940s, it was still more modern than the tailwheel layout used by many fighters. For jets, tricycle gear made practical sense. It kept the aircraft level on the ground and made takeoff and landing behavior more suitable for the new propulsion system. The cockpit was placed in the central section. The pilot did not lie flat, despite some popular claims. He sat inside the wing, enclosed by the machine around him. Picture that cockpit. A narrow space inside an experimental jet wing. The engines closed behind and beside the pilot. No long fuselage stretching forward. No tail visible behind. Just the curve of the wing and the runway ahead. For a test pilot, it must have felt like sitting inside an idea before anyone had fully proven it. Planned combat versions were expected to carry heavy cannon, likely 30mm weapons. That would have made sense for an interceptor intended to attack Allied bomber formations. A high-speed jet with heavy guns could, in theory, make fast passes against bombers and escape before escort fighters could respond. But there is a sharp difference between a planned fighter and an operational fighter. The Ho 229 never reached that stage. Its armament remained part of the projected future of the design, not a proven combat record. Still, the concept was bold. A single-seat jet flying wing, low drag, buried engines, heavy cannon, high speed, all of it wrapped in a shape that seemed to belong not to 1945, but to some later decade. That is why the aircraft became so easy to mythologize. It looked like the future. And when a machine looks like the future, people often assume it possessed future capabilities. But history demands patience. The first Ho 229 prototype was not a jet-powered fighter. It was a glider. The Ho 9V1 flew without engines. That was a logical step. Before risking a powered aircraft, the designers needed to prove that the basic configuration could fly and be controlled. The V1 showed that the wing could leave the ground and behave well enough to continue development. But a glider test is only a beginning. It does not prove jet performance. It does not prove high-speed handling. It does not prove engine integration. It does not prove combat usefulness. It proves one thing. The idea is not dead on arrival. The real test came with the V2. The powered prototype carried two Junkers Jumo 004 turbojet engines. These engines were among the most important aviation technologies of the war. They also reveal why the Ho 229 was both promising and troubled. The Jumo 004 was an axial flow turbojet. That means air passed through a series of compressor stages arranged along the engine's axis, then entered combustion chambers, then drove a turbine and produced thrust. This layout became fundamental to later jet development. For its time, it was remarkable. But it was not mature by modern standards. The engine could be temperamental. It had limited service life. It required careful throttle handling. It needed materials that were hard to obtain under wartime pressure. And it burned fuel at a rate that made range a constant concern. This is why the Ho 229's airframe and engines must be understood together. The flying wing was not just a dramatic shape placed around jets. It was an attempt to compensate for the limitations of early jet power. The cleaner the aircraft, the less thrust was wasted overcoming drag. The less drag, the more speed. The more efficient the shape, the better the chance of useful range. In theory, the Ho 229 gave the Jumo 004 a more efficient body to push through the air. That was the revolutionary part. But theory had to meet test flying. And test flying is where aircraft become honest. In early 1945, the V2 took to the air. Germany was already collapsing. Allied armies were advancing. American and British aircraft were striking transportation, factories, fuel plants, and airfields. The Luftwaffe was fighting with too few trained pilots and too little fuel. Against that background, a strange jet wing began its brief, powered test life. The aircraft reportedly flew only a few times. Those flights were enough to suggest promise. They were not enough to prove the legend. The V2 showed that a jet-powered flying wing could fly. That alone was significant. But the aircraft still needed refinement. It still needed a longer test program. It still needed to prove its behavior across different speeds, weights, engine conditions, and emergency situations. Then came February 18th, 1945. During a test flight, the V2 suffered an engine failure. For any early jet, that was serious. For a twin-engine flying wing still in development, it was deadly. The pilot, Erwin Ziller, was killed in the crash. The image is stark. A prototype wing falling from the sky. A test program interrupted by smoke, wreckage, and loss. A future that lasted only minutes in the air. This crash is one of the most important facts in the Ho 229 story. It does not mean the design was worthless. Many experimental aircraft have suffered accidents. Many great aviation advances came through danger and sacrifice. But it does mean the aircraft was not ready. It had not completed the long, punishing process that turns an idea into a weapon. It had not proven its projected range. It had not proven its combat speed in service form. It had not proven its weapons. It had not proven that ordinary units could maintain it. It had not proven that Germany could build it in numbers. And by early 1945, Germany no longer had the luxury of time. That is the hard truth behind many late-war German aircraft. Innovation alone does not win a war. A weapon has to be built. It has to be fueled. It has to be maintained. It has to be flown by trained crews. It has to be supplied with spare parts. It has to survive operational use. The United States and its allies understood this at a scale Germany could no longer match. American air power was not built on one secret machine. It was built on factories, training fields, logistics, maintenance, fuel, crews, escorts, bombers, carriers, and a system that could sustain pressure every day. The Ho 229 was a bold machine, but it was born inside a system that was dying. Work continued on the next prototype, the V3. This is the aircraft that survives today. The V3 was being built with the involvement of Gotha Wagenfabrik, the company tied to the Go 229 production designation. It represented a more developed airframe and the closest surviving physical example of what the design might have become. But the V3 never flew. That point matters. When people see the surviving HO 229, they sometimes imagine a tested combat aircraft. They imagine a machine that had already proven its full promise. In reality, the V3 was unfinished when American forces captured it. Picture the scene near the end of the war. Not a secret runway full of operational flying wings. Not a squadron waiting to launch. Not a hidden force that might have reversed the air war. Instead, American troops found an incomplete aircraft in the wreckage of a collapsing Germany. A strange wing, a captured airframe, a piece of technology too unusual to ignore. Its center section showed the steel frame, the cockpit area, and the engine installation. Its wooden wings revealed the material choices and construction methods. It was part aircraft, part artifact, part unfinished question. American forces took it. That decision was practical. The United States was gathering German technology, not because every German idea was successful, but because some ideas were worth studying. Jet engines, swept wings, rocket research, high-speed aerodynamics, advanced weapons, radar and electronics. The Ho 229 belonged to that larger post-war harvest of knowledge. It crossed the Atlantic not as a defeated superweapon, but as evidence. Evidence of what had been attempted. Evidence of what had not been completed. Evidence of how far aircraft design had been pushed under the pressure of war. The surviving V3 eventually became part of the Smithsonian's National Air and Space Museum collection. Over time, conservation work helped historians and technical specialists examine what was really there. That physical evidence is important because the Ho 229's reputation grew far beyond its test record. And nowhere did that happen more than with the subject of radar stealth. Today, when people see the Ho 229's shape, they often think of the Northrop B-2 Spirit. The comparison is easy to understand. Both aircraft are flying wings. Both lack conventional tails. Both have a smooth, broad, almost alien silhouette. But visual resemblance can mislead. The B-2 was the result of decades of American research. It required advanced radar science, computer modeling, precision manufacturing, specialized materials, systems integration, and digital flight controls. It was not just a shape. It was an entire technological ecosystem. The Ho 229 was a wartime experimental aircraft built from steel, wood, glue, and early jet technology. That does not make it crude. It makes it different. A flying wing can reduce radar reflections in some ways. A conventional vertical tail can create strong radar returns. A smooth tailless shape may be harder to detect from certain angles than a normal aircraft with a fuselage, tail, and external engine nacelles. So the basic idea that the HO-229's shape might have had a lower radar signature is plausible. But that is not the same as modern stealth. Modern stealth is not simply an aircraft with no tail. It is a controlled system. Edges are aligned. Engine inlets are shaped. Exhaust is managed. Cockpit reflections are considered. Antennas, seams, doors, gaps, weapons bays, and materials all matter. The aircraft is designed, tested, measured, adjusted, and maintained around radar behavior. The HO-229 did not have that kind of development program. Some later claims suggested that the aircraft used charcoal or carbon material in its construction to absorb radar waves. This idea became famous because it gave the story a secret ingredient. It turned an aerodynamic aircraft into a hidden radar-evading weapon. But later technical examination of the surviving V-3 has not strongly supported the idea that it used a deliberate radar-absorbing material in a modern sense. The better conclusion is more careful. The HO-229 may have had some radar signature advantages because of its layout. Its shape may have made it less visible than conventional aircraft under certain conditions. But the strongest evidence points to aerodynamics as the main purpose. Speed, range, and drag reduction drove the design. Radar reduction, if present, was secondary at best. That does not make the story smaller. It makes it cleaner. The real HO-229 does not need to be called a stealth bomber to be remarkable. It was already remarkable as a jet-powered flying wing built during World War II. The myth says it was a lost miracle. The evidence says it was a bold, incomplete experiment. For a serious documentary, the evidence is better, because it creates a deeper kind of tension. Not, what if the Nazis had a secret superweapon? But how close did wartime engineers come to ideas that would only become practical decades later? That question is more powerful. It allows us to respect the engineering without exaggerating the weapon. It also allows us to recognize American achievement after the war with proper perspective. The United States had its own flying wing tradition. Jack Northrop had pursued flying wing aircraft independently for years. After the war, Northrop built large experimental flying wings, including the XB-35 and YB-49. These aircraft explored many of the same aerodynamic questions. They also exposed the same problems: stability, control, pilot workload, engine integration, operational practicality. The dream of the flying wing was not easy for anyone. The reason later American flying wing aircraft became practical was not because one wartime German prototype had solved the problem. It was because later engineers had tools the 1940s did not have: digital flight controls, advanced materials, better engines, radar measurement, computer-aided design, precision manufacturing, a stronger industrial base. The HO-229 looked forward, but it did not possess the future. That distinction is essential. Its shape hinted at possibilities. It did not deliver them. To understand that, compare it with aircraft that did reach the war. The Messerschmitt Me 262 was Germany's operational jet fighter. It was fast and dangerous. Allied pilots respected it. American bomber crews had reason to fear it when it appeared. It carried heavy armament and could attack bomber formations at speeds piston fighters could not easily match. But even the Me 262 came too late and in too few numbers to change the outcome. It used a more conventional aircraft layout: fuselage, wings, tail, engines under the wings. Compared with the HO-229, it looked less futuristic. But it was more mature. It could be built. It could be armed. It could be assigned to units. It could fight. The Arado R-234 tells a similar story. It was Germany's operational jet bomber and reconnaissance aircraft. It was fast, impressive, and historically important. But it too arrived when Germany's strategic position was already broken. Compared with these machines, the Ho 229 was more radical. But radical is not always better in wartime. A conventional design can reach the battlefield sooner. A radical design can spend its life in testing. That is exactly what happened. The Ho 229 promised extreme performance. It promised a cleaner way to use jet propulsion. It promised a form that eliminated much of the drag built into traditional aircraft. But it remained a prototype program. The famous speed and range claims must be handled carefully. Could a fully developed Ho 229 have been fast? Yes, very likely. Was the idea of a jet flying wing approaching 600 miles per hour impossible? No. The low drag layout and jet engines made high speed plausible. But did the aircraft prove those numbers in combat-ready form? No. Did it demonstrate the full 3 × 1,000 goal? No. Did it carry out operational missions? No. That is the difference between projected performance and historical performance. A projected figure lives on paper. A test figure comes from controlled trials. An operational figure comes from real service. The HO 229 had the first category, a small amount of the second, and none of the third. That does not make it unworthy of study. It means we must study it honestly. Late-war German weapons often suffer from the same problem in popular history. The more incomplete they were, the easier they are to exaggerate. Because they never fought long enough to show their flaws, people imagine them at their best. The Ho 229 is a perfect example. Its unfinished status became part of its legend. What if the engines had been better? What if production had started earlier? What if it had flown against Allied bombers? What if it had been invisible to radar? What if it had changed everything? These questions are natural, but they can also become a trap. By 1945, Germany did not need one impressive aircraft. It needed an entire functioning war system. It needed fuel for training and operations. It needed experienced pilots. It needed secure factories. It needed reliable engines. It needed spare parts. It needed time to test, fix, and produce. It needed airfields that were not being bombed. It needed supply lines that still worked. It had very little of any of that. American and Allied power had become overwhelming, not because every aircraft was futuristic, but because the whole system worked. Bombers flew in numbers. Fighters escorted them deep into enemy territory. Factories replaced losses. Crews were trained. Fuel was delivered. Damaged aircraft were repaired. New tactics were developed. That is how modern wars are won. The Ho 229 was a fascinating aircraft, but it was not a substitute for strategy, logistics, and industrial power. This is why the surviving V-3 is so haunting. Imagine it after capture. The war around it is ending. The regime that built it is collapsing. The airframe sits silent, with no combat history and no future in German service. Its plywood wings are not the wings of a victorious weapon. They are the remains of an ambition that ran out of time. American personnel examine it not as a threat still to be feared, but as a technical object to be understood. The aircraft is loaded, moved, studied, and eventually preserved. Decades later, historians and conservators can look at the actual machine. They can examine its materials. They can inspect its construction. They can compare claims against evidence. That is where the artifact becomes more powerful than the legend. A myth can say anything. An aircraft tells a narrower story. Its structure tells what was built. Its unfinished details tell what was not completed. Its materials tell what the designers had available. Its damage, coatings, adhesives, and construction choices tell how theory met reality. The Ho 229 survival gives us something rare, the chance to confront the legend with the object itself. And the object says this: the project was real. The design was advanced. The ambition was extraordinary. But the aircraft was not a mature weapon. That balanced truth is what makes the Ho 229 worth a full documentary. It is not just an airplane story. It is a story about how technology is remembered. Some machines earn their fame through combat. The P-51 Mustang earned it in the skies over Europe. The B-17 earned it over Germany. The F-6F Hellcat earned it over the Pacific. The Me-262 earned it as the first operational jet fighter. The Ho 229 earned its fame differently. It earned it through appearance, possibility, and mystery. It is famous partly because it did not get the chance to reveal its limits. That is why the script of its history must be careful. We should not mock the aircraft. It was too serious for that. We should not glorify it. It served a criminal regime. We should not inflate it into a superweapon. The facts do not support that. We should place it where it belongs, at the edge between wartime desperation and post-war aviation possibility. The men who built it were not designing in peace. They were working inside a nation already responsible for catastrophic destruction and mass murder. The aircraft belonged to the military ambitions of Nazi Germany. That context cannot be removed. But the engineering questions inside the aircraft were real. How can drag be reduced? How can a tailless aircraft be controlled? How can jet engines be integrated into a wing? How can range be improved when engines consume fuel so quickly? How can a high-speed aircraft be built when materials are scarce? Those questions continued after the war, under very different nations and very different purposes. The Ho 229 sits at that crossroads. It is both a wartime weapon project and a technical experiment. Both facts matter. If we only see the machine, we miss the moral context. If we only see the regime, we miss the engineering lesson. A serious history must hold both. By the time American forces captured the V-3, the war in Europe was nearly over. The aircraft had no chance to enter service. It had no chance to mature. Its future as a German weapon ended before it began. But its future as a historical artifact was just beginning. After the war, the study of captured German technology influenced many fields. Jet propulsion, swept wings, rocket engineering, high-speed aerodynamics, and other areas became part of the post-war race for knowledge. The Ho 229 was not the key to all of that, but it was part of the evidence. It showed that flying wing ideas had been pushed into jet-age form. It showed that low-drag thinking had reached a dramatic shape. It showed that engineers were already wrestling with questions that later aircraft would revisit. The important word is revisit. Later flying wings did not simply copy the Ho 229. They solved problems the Ho 229 had not solved. That is especially true of control. A tailless aircraft can be efficient, but it must be stable and controllable. In the 1940s, designers had to achieve that through shape, balance, mechanical controls, and pilot skill. Later aircraft gained something far more powerful. Computers. Digital flight control systems can make tiny corrections constantly. They can keep unstable or marginally stable aircraft under control. They can allow shapes that would be exhausting or impossible for a pilot to manage alone. The Ho 229 did not have that. It had clever aerodynamics. It had mechanical systems. It had brave test pilots. It had a very short test program. That is why we should avoid drawing a straight line from the Ho 229 to the B-2. The visual connection is tempting, but the technical path is far more complex. American flying wing development had its own deep roots. Modern stealth and modern control systems emerged from decades of research. The Ho 229 was a signpost, not a blueprint. That may sound less dramatic. It is not. A signpost can still matter. It can show that a certain direction existed. It can reveal what engineers imagined before the tools were ready. It can help us understand why some ideas return again and again in aviation. The flying wing is one of those ideas. It promises purity. It promises efficiency. It promises a machine where almost nothing is wasted. But it demands a price. Control, complexity, precision. The Hortens spent their lives chasing that promise. The Ho 229 was their most famous wartime attempt. And because it arrived at the end of World War II, it became wrapped in the drama of collapse. That drama is visual. A runway in winter, a jet wing beginning its takeoff roll, the howl of two early turbojets, mechanics watching from the edge of the field, a pilot inside a machine unlike anything around him. Then, on a later flight, the failure of an engine, the struggle to control the aircraft, the crash, the silence after impact. Then another image, an unfinished V-3 in a captured facility, American soldiers and technical teams standing around a strange wing that never had time to become what its designers imagined. These are the images that should guide the story. Not fantasy fleets, not secret bases full of invisible bombers, not claims beyond the evidence. The real scenes are powerful enough. They show ambition under pressure. They show engineering at the edge. They show how war accelerates ideas and destroys the conditions needed to perfect them. They show why the Ho 229 still captures attention. For viewers who love World War II aviation, the Ho 229 stands apart because it does not look like the war we know. It does not look like a B-17, a P-51, a Lancaster, a Thunderbolt, a Corsair, a Spitfire, or a Messerschmitt. It looks like an interruption. A silhouette from the future dropped into the last act of the war. But the war was not decided by silhouettes. It was decided by men, machines, factories, fuel, training, courage, and endurance. American bomber crews flew through some of the most dangerous skies in history. Fighter pilots fought for control of the air. Ground crews kept aircraft flying. Factories across the United States produced engines, airframes, radios, ammunition, tires, instruments, and spare parts in staggering quantities. That was power, not just invention, sustained power. The Ho 229 reminds us that a brilliant prototype is not enough. A nation at war must turn design into production, production into deployment, and deployment into sustained combat effect. Germany could no longer do that. The aircraft was too late, too untested, too dependent on fragile engines, too demanding for a collapsing industrial system. That does not make it a failure as an idea. It makes it a failure as a wartime solution, and that difference is important. As an idea, the Ho 229 remains fascinating. As a weapon, it arrived too late to matter. As a myth, it grew far beyond the evidence. As an artifact, it still speaks. It tells us that aviation history is not a straight line. Some ideas appear early, disappear, and return later. Some machines look ahead but cannot cross the gap between imagination and reality. Some prototypes become famous not because they succeeded, but because they reveal the future in unfinished form. The Ho 229 is one of those machines. It was a flying wing before the world had the tools to make flying wings fully practical. It was a jet aircraft before jet engines were reliable enough for easy service. It had a shape that may have reduced radar reflections before stealth became a disciplined science. It was built with advanced thinking and old materials. It was both futuristic and fragile. That contradiction is the core of its story. A wooden jet wing, a high-speed dream in a collapsing war. a captured relic that later generations turned into a legend. To tell the story well, we must stay close to the evidence. The Horten brothers came from glider experimentation. The flying wing concept aimed to reduce drag and improve efficiency. The Ho 229 was linked to ambitious speed, range, and payload goals. It used early German turbojet technology, especially the Jumo 004. The V1 flew as a glider. The V2 flew under power and crashed. The V3 survived unfinished and was captured by American forces. Its stealth reputation is partly understandable, but often overstated. Its real importance lies in its engineering ambition, not in combat achievement. That is the historical foundation. Everything else must be handled with care. There is nothing wrong with asking, what if? Good history often begins with curiosity. But good history cannot end there. It must return to what happened. And what happened is clear. The Ho 229 did not alter the air war. It did not stop Allied bombing. It did not threaten America's industrial dominance. It did not appear in numbers. It did not become operational. The war moved past it. American and Allied forces won through a combination of courage, strategy, technology, production, and endurance that no single late-war German aircraft could overcome. Yet the Ho 229 remained, not in the sky, in memory, in storage, in museums, in debate, in the imagination of aviation enthusiasts who see its outline and wonder how such a thing could have existed in 1945. That wonder is valid. The key is to aim it in the right direction. Do not wonder whether it was a secret magic weapon. Wonder instead how two brothers moved from gliders to a jet-flying wing. Wonder how early jet engines forced designers to rethink the entire shape of the aircraft. Wonder how a machine can be both ahead of its time and far from ready. Wonder how myths grow when prototypes leave behind more questions than answers. And wonder what it must have felt like for American investigators to stand before that captured airframe and realize they were looking at a future that Nazi Germany would never possess. That final point matters. The Ho 229's shape may have pointed forward, but the future did not belong to the regime that built it. The future belonged to those who survived the war, learned from it, and built with greater discipline and greater purpose. It belonged to nations that could test, refine, manufacture, and operate complex machines at scale. It belonged to engineers who could turn dangerous ideas into reliable systems. It belonged to pilots and crews who would fly the next generation of aircraft under new conditions, with new tools, and with lessons paid for in war. The Ho 229 was left behind at the border between those worlds. Behind it was the age of wartime improvisation and desperation. Ahead of it was the age of jet aviation, high-speed research, advanced control systems, and eventually stealth. It did not cross that border, but it stood close enough to make history notice. That is why the aircraft still matters more than 80 years later. Not because it was the first true stealth bomber, not because it could have won the war, not because every legend about it is true. It matters because it shows how far aviation thought had advanced by the end of World War II, and how far it still had to go. The Ho 229 was a dream of low drag and high speed, a dream wrapped in plywood and steel, a dream powered by engines that were brilliant but fragile, a dream tested too late under a regime already collapsing, a dream captured by the victors before it could become reality. And like many unfinished dreams, it became larger in memory than it ever was in life. The responsible historian has to bring it back to scale, not to diminish it, to see it clearly. Because when we see it clearly, the Ho 229 becomes more than a myth machine. It becomes a lesson in aviation. It teaches that shape matters, but systems matter more. It teaches that innovation can be real even when a project fails. It teaches that late war wonder weapons often reflected desperation as much as genius. It teaches that the difference between a prototype and a combat aircraft is vast. It teaches that the future is not won by imagination alone. It must be engineered, tested, produced, maintained, and flown. In the end, the Horten Ho 229 was not the aircraft that changed World War II. The outcome had already been shaped by Allied air power, American industry, fuel, training, logistics, and the relentless pressure of total war. But the Ho 229 did change the way people remember the edge of wartime aviation. It remains one of the most striking experimental aircraft ever built. A tailless jet wing born from glider experiments. A desperate attempt to achieve speed and range with a cleaner shape. A machine that looked forward while the world around it collapsed. And today, the surviving airframe stands as something more honest than legend. It is not a monument to victory. It is a relic of failure. It is not proof of a lost superweapon. It is proof of an unfinished path. It is not the Nazi B-2. It is the Ho 229, a dangerous, brilliant, incomplete aircraft from the final months of the Second World War. A machine that rose briefly into the air, then fell back into history. And from that history, it still asks the same question it asked in 1945. How far can aviation go when engineers remove everything except the wing? The answer would not come from the Third Reich. It would come later, from patient research, from disciplined testing, from industrial strength, from nations that understood that the future of flight was not built by myth. It was built by proof. That is the real legacy of the Horten Ho 229. A flying wing, a jet prototype, a captured relic, a warning against easy legends, and one of the most unforgettable aircraft of World War II.